We're going to refresh on the two different types of sequences that we focus on. Keep in mind that in math, it is not restricted to only these two types of sequences. We are looking at arithmetic and geometric, but there are sequences in series, the Fibonacci sequence. Many of you probably have heard of that. There's like a harmonic series. Many of you will touch on that when you get into calculus. But again, these are the two that we're focusing on, arithmetic and geometric. And so an arithmetic sequence is, first of all, let's describe the difference between a sequence and a series. Does anybody know? Difference between a sequence and a series? It's a very simple, yeah. No, that's infinite and finite, so that's the difference there, but great guess. It's a real basic. A sequence is a list. Oops, a list. A series is a sum. And that's it. That's the only difference between the two of them. So when I look at an arithmetic sequence, I am looking at a list of numbers. And our first number is A subscript 1. You could actually use any other letter, but we typically use A. This is A subscript 1, and I refer to it as A sub 1. Sometimes people think I'm saying A sub 1. Nope, it's A sub 1, and that's because the subscript here is 1, and all that represents is the term number. So if my subscript is 1, it is the first term in this particular sequence. A sub 1 is followed by A sub 2, which is followed by A sub 3. I think you get the pattern, right? That means that A sub 3 represents the third term in this sequence. This list can go on and on and on. It can even go infinitely, but we sometimes talk about other terms that are further down in the sequence, and we talk about them with an n variation of a subscript. So when I see A sub n minus 1, that is the term that comes before A sub n, and A sub n is followed by A sub n plus 1, and again representing any term down the road. It could be 50, and so the 50th term is preceded by the 49th term, which is 50 minus 1, and is followed by the 51st term, which is 50 plus 1. So that's just terminology. Again, a big part of what we do in math is learning how to interpret the math language, and that's what all these symbols are. So arithmetic sequence in general looks like this. What makes it arithmetic? Every move I make, I have a common difference between the two of them. So to get to A sub 1, I would add this common difference to get to A sub 2, and to move on, I would add that same D, and to continue on, I add the same D. And so it's a constant common difference. It's known as a common difference, or it's talked about as a common difference, because the D is found by taking the second term minus the first term, which should match the third term minus the second term. That's where the difference comes in, which should match the fourth term minus the third term, which should match the n plus 1 term minus the nth term. And I can go on and on and on forever, but that's how I can find my common difference if I don't see it right away. So what makes an arithmetic sequence is, I'm going to change my color so it stands out. It is a pattern of numbers with a common difference.
Good morning. At this time, please send the bowling club, shooting team, and HOSA down to the small gym. Again, that was the bowling club, shooting team, and HOSA should head down. And that will conclude our pictures for this morning. Thank you for your patience and cooperation.
All right, so a pattern of numbers with a common difference. And when we talk about something called the explicit formula, all it is a form that will generate any sequence number that I want. And we have two variations of it. We have the one that you'll see often, a sub n can be found. That means any term can be found by taking d times n minus 1 plus a sub 0. Sorry. Plus a sub 1. And then we also have the simplified variation, and that one is a sub n is equal to dn plus a sub 0. These things can be flipped around. Sometimes we see it in the other form, and I'm just going to jot it on a different piece of paper because I didn't leave a whole lot of room here. But just know that this could be written, this first one could be written as a sub n equals a sub 1 plus d times n minus 1, or it can be written as a sub n equals a sub 1 plus n minus 1 times d. Those are all variations of the exact same thing. I write it in this form here because it looks more like a linear equation, like a slope-intercept form, when it's in this simplified. This is like y equals mx plus b. And that represents the same thing. Arithmetic sequences are very linear. Okay? This one is also sometimes written as a sub n equals a sub 0 plus dn. And again, the reason that I write it the other way is because I like the connection to slope-intercept form. Okay? Where does it start? How does it change? Kind of talk that we have here. So these are the other variations that you might see. If you look it up online, you might see one of these. All right? So we are going to be looking at a sequence, or you should be able to. Your goal is to be able to look at a sequence. First of all, recognize whether or not it's arithmetic, and then be able to write an explicit formula to represent that sequence. So when I look at this first problem here, is this arithmetic? Is there a common difference between each term? Is 23 minus 26 the same as 20 minus 23? The same as 17 minus 20? Yes, and it is. My common difference here is negative 3. Now, if I'm going to use this first variation to write my formula, I am going to have to simplify it. And a lot of people forget that they have to do that. So I usually use this second variation to find my formula. I think it gets the job done quicker and more efficiently. The only problem is I need to find a sub 0, and a sub 0 is the 0th term, meaning it doesn't even exist in this problem. But we can find it because I need to go, if this had a number before 26, what would it be? So if this had a number before 26, it would probably be, great, excellent. And so that is my a sub 0. It's a real quick move, and it saves me the chore of having to distribute and solve and clean up and whatever, blah, blah, blah. So my explicit formula is d, which we decided was negative 3, times n, and I think of that as the change. Again, it's like the slope. How is this changing? I'm subtracting 3, I'm subtracting 3, I'm subtracting 3. So negative 3n plus that imaginary term that would have come before the first term if there was a number before the first term. That's a sub 0, the non-existing term in this problem. This is my simplified explicit formula. And so this formula can be used to find any term number I want. I could find the 50th term, I could find the 100th term, but this time they said, why don't you go ahead and find the 36th term? So a sub 36 is negative 3 times 36 plus 29. I just have to plug that in my calculator or whatever you need to do to get that. Negative 108 plus 29. So that would be negative 79. And that is part of my answer, and this is the other part of my answer. Good? Feel okay? Explicit formula. Again, recognize that it's arithmetic. Come up with a formula that represents this sequence, this unique sequence, and then use it to find a given term number. So we'll do one more and then I'll let you guys try one. I'm given different information here. In this one, they don't give me the list, but they tell me what's going on. So I could actually create this list or this sequence, this list of numbers. It starts at 26, and every time this tells me I add negative 200. And I hope that Luke isn't playing on his phone. I hope that he's using it as oh, it is a calculator. Jeez, I'm sorry. Negative 174, because you're doing the math, right?
Yeah.
Okay. Is that negative 174? 26 minus 200? Yeah, okay. And then minus 200 again, negative 374. Good, is my math all right? And then blah, blah, blah. Do I need to do that? I really, really don't. Because in order to write the formula, they already gave me D. And I just need to figure out what would come before 26, the first number, if there was one before that. 226, great. So this is a sub n equals negative 200n plus 226. So there's my formula. And now I need to find my, in this case, 21st term. So a sub 21 means take 21 and replace n with it, because that's what that represents. This is the 21st term. 21 is n. Negative 200 times 21 plus 226. And then do the math on that one as well. Negative 3,974. Okay, great. So again, those are our two answers. Why don't you give the next one a try? Math. Give it a whirl, give it a whirl. We'll compare in a little bit. Give it a check when you get a chance, or at least to see if you're on the right track as far as that. Does anybody agree with me? Seem reasonable? I got a lot of looks like I'm doing something wrong. What did I do bad? Yeah. Is what?
39 equals 209.
Oh. Yeah, follow the directions, lady. Okay. Yeah, okay. Oops. All right, way off. Way off. Was anybody doing what I was doing? Okay. Was that first? Okay. So we have a sub 39 is negative 209. So what I need to do is find a sub 0. So negative 209 is equal to negative 5 times 39 plus a sub 0. So this is a way different look at it. Okay. Sorry about that again. So I'm going to have to do the math on this one here. Negative 209 is equal to whatever I get when I multiply these together. So that, I think, is negative 199? 195. 95, thank you. Plus a sub 0. And when I add 195 over, I get 14. Negative 14 for a sub 0. Okay, which allows me then to rewrite my formula as a sub n equals negative 5n minus 14, or I can use I can use that to find a sub 30. Negative 5 times 30 minus 14, and that is negative 164, I believe. Is that better? Okay, a little bit different. We changed up the notes a little bit because, again, we're still recovering from those snow days. So I forgot that we did not give extra samples of each one. But here is my formula, and here is my a sub 30. All right, we can also use that formula that we set up, that explicit formula, to help us find missing terms and help find the sequence. Now you can, bless you, to whoever sneezed, I didn't see you, but you can do a guess and check to find these. What am I adding each time? Or you can do it very algebraically. And I'm going to always show you the algebraic way, but if you feel like, no, I can figure that one out without doing the algebra, great. It is good to try the algebra just in case. So what I'm given is a piece of this sequence. And the piece that I have starts at, so my a sub 1 here is negative 37, and it ends at, so a sub 2, a sub 3, a sub 4, a sub 5, a sub 6, a sub 7, it ends at a sub 7. Okay? That's what I'm given. And so what I do is, bless you, I try to figure out what that common difference is. And I do that by going through and kind of just plugging this stuff in here. If I end at negative 55, and I started at negative 37, I added D a certain amount of times, and that certain amount of times comes from subtracting where I ended and where I started. That's where the n minus 1 part comes from in that original explicit formula. So I am going to subtract D 7 minus 1 times. 7 minus 1. So this is negative 55 is equal to negative 37 plus 6D, basically is what it boils down to. Where I end, where I start, this is going to help me find my common difference. So algebraically, I'm going to work my way through this. That means that add 37, is that 18? 18 is equal to 6D, divide by 6, so 3 is D. That means I add 3 each time. So negative 37 plus 3. Oops, I missed it. Nope, that should have been a negative. That should be a negative. So net plus negative 3 gives me negative 40. Plus negative 3 gives me 43, negative 43. Negative 46. Negative 49. Negative 52. And if I did it correctly, if I plus negative 3, that should happen again. Okay? So again, you might be able to figure out what's going on just by guessing and checking, or you can go through it algebraically, and I'm going to go through it algebraically one more time. So this is a sub 1 is 13, 2, 3, 4, 5. A sub 5 is 813. I ended at 813, but I started at 13. And I added D 5 minus 1 times. That number minus that number. Or 813 is 13 plus 4D. So 800 is 4D. And so 200 is D. 213, 413, 613. I can fill in my value. Good? Okay? Again, guess and check if you want. Guess and check is kind of difficult sometimes, so I don't recommend that being your sole way of doing that. All right? So, arithmetic is where we start. Up next is geometric. Geometric is the other one that we want to focus on. where arithmetic is adding every time, geometric is multiplying every time. And so when I look at a geometric sequence, I define it as a pattern of numbers with a common ratio. And my common ratio is known as R. I'll put that down there. We should do the same thing for our common difference. I'm going to slide that up. My common difference, as you saw, is known by D. And in fact, if I'm given multiple sequences and I have information that contains an R in it, I know that it's going to be a geometric sequence. If I have an information that contains a D in it, I know it's going to be arithmetic. If I just have the list of sequences, then I can tell if it's arithmetic or geometric by whether we're adding or multiplying each time. Okay? So this is a pattern of numbers with a common ratio. Again, I start it the same way. It's got a first term. It's got a second term. It's got a third term. It's got a whole bunch of terms after that. This doesn't look anything different than our arithmetic sequence looked like. We have a term before the nth term, and a term after the nth term, and we can have infinitely many more terms after that. What makes it different is that from term to term, it is times r. I don't like using that times symbol, but times r, it seems so archaic, it seems so like back into second grade or whatever, but I just want to point out that it's multiplication. A geometric sequence is not division. If it gets smaller, you're multiplying by a fraction or a decimal. You are never dividing when you're doing this, okay? And this goes on and on and on forever, and we can write R as, or find R, if you can't tell what R is, you can find R by setting up a ratio. A sub 2 divided by a sub 1 should be the same as a sub 3 divided by a sub 2, which would be the same as a sub 4 divided by a sub 3, which should be the same as a sub n plus 1 divided by a sub n. So you can find your ratio if you can't visually see it by setting up a fraction and making sure that it's consistent. We only have one explicit formula for geometric, and that one explicit formula is a sub n is equal to a sub 1 times r to the n minus 1 power. You don't always need the parentheses on here. You could use a dot for a times symbol, but I will always use the parentheses, and the reason that I do that is because then I make sure that my negative number has the parentheses around it before I raise it to a power. And that's a big thing that's going to cause potential issues when we are evaluating with these, all right? So a sub n, a sub 1, r to the n minus 1 power. What time are we done today? 10:28. Okay. So I think we're going to go through just these on this page, and then we'll do the sequence or the series part tomorrow, okay? All right, so explicit formula. I always think the explicit formula is much easier. Notice that the values that we're finding, like I'm only finding the 9th term, the 12th term. I'm finding low number terms because when you have a geometric sequence, it grows fast. And so if you're multiplying by 3 times 3 times 3 times 3, before you know it, you're in the thousands, in the 10,000s, in the 100,000s. So we're not going to go too far down the road, because if I try to find the 100th term here, I'm going to end up overloading my calculator. It won't even be able to find it for me. But what I want to do is check and see if I can find out my R. And again, sometimes you can tell by looking at it, but if not, I do negative 12 divided by 4. Make sure that equals 36 divided by negative 12. Make sure that equals negative 108 divided by 36. And in fact, it does. I end up with negative 3 for all of those. Good? So that's my R. My R is negative 3. And so my form is a sub n equals my first term. I don't have to go back to an imaginary 0 term, okay, because there's no simplifying that's going to happen here. So I just start with my first term, and I multiply it by negative 3 raised to the n minus 1 power. And so my ninth term is, so this is answer number 1 here. My ninth term is a sub 9 equals 4 times negative 3 raised to the 9 minus 1 power, which is 4 times negative 3 to the 8th power. You do have to be really careful when you're plugging this in your calculator again, because these negatives and powers, the even powers are going to make this come out positive. The odd powers will remain true to their sign. And so if you forget that parentheses, it's going to mess up with it's going to mess up your answer. And so I'm reminding you, please, please, please be very careful with that. So 4 times negative 3 to the 8th power, sometimes to avoid any ickiness in it, because I know it's an even power, I will just put 4 times 3 to the 8th power, because I know it's going to come out positive. And on my calculator, I might have to use my caret key. Some of you have a different key. If you can't find how to raise it to a power, let me know. But that is 26,244. 26,244. Everybody good? Anybody have a problem? Okay. On this one, I have my first term and I have my R, so really, like, there's not even anything I have to do. They give me all of the information that I need. I can jump right in. A sub n is my first term, negative 1 times negative 4 to the n minus 1. Oftentimes you'll see a problem like this written just as the opposite of negative 4 to the n minus 1. And a question that I get from a lot of people is, well, can't I just make it positive 4? No. Again, this negative is attached to this power. This 1 inside the parentheses is attached to the power. And so if this is an odd power, it will come out negative. But if this is an even power, it'll become positive, and that's going to change the sign as you go. So fight that urge that we have sometimes to like try to simplify things. This is not a positive 4 to the n minus 1 power. So if I'm finding the ninth, a sub n is equal to the opposite of negative 4 to the 9 minus 1 power, or a sub n is equal to the opposite of negative 4 to the 8th. And so the opposite of negative 4, parenthesis raised to the 8th power. Again, if you can't find your power key, let me know. Most of them are caret keys on our calculators. I get negative 65,536. So negative, this is a sub 9, 65,536. And here is my, okay, any questions? You good? Sure? Okay. All right, so here's our next one. We have another situation where I think this one kind of brings us into what is going to come next. So when we use that kind of formula to set it up, if I know the sixth term is, hello, Mrs. Rita. Yeah, yeah. Yeah, you bet. Bye. Henry, I think you have something for Trish.
Oh,
She asked if you could bring that up. Okay, so this is the sixth term I'm given. So I know that 486, negative 486 is equal to the first term times negative 3 to the 6 minus 1 power. So I'm just using that a sub n equals a sub 1 times r to the n minus 1 power. If I know the sixth term, I can find a sub 1 using that. There's another way you could find a sub 1 as well. You can set up that sequence and just keep dividing by negative 3, divide by negative 3, divide by negative 3, divide by negative 3. Fine, if that works best for you. Sometimes it's putsy and sometimes we count wrong, so I don't recommend that way. This is negative 486 is equal to a sub 1 times whatever negative 3 to the 5th power is. Make sure you get those parentheses, negative 243. So that means 2 is equal to a sub 1. Good? Feeling it? So that means my formula is a sub n equals 2 times negative 3 to the n minus 1 power. And a sub 12 is 2 times negative 3 raised to the 12 minus 1. Bless you. Again, just plug that in. 2 parenthesis negative 3 parenthesis raised to the 11th. Make sure you put the power on the outside of the second parenthesis. I got negative 354,294. That's negative 354,294. Okay, so 2 more. The last 2 again are like the 2 with arithmetic, where if you want, you can try to work your way through and figure out what's happening, but if you get stuck and you can't find it, sometimes it's more efficient to just set up the algebra. I keep trying and I can't come up with the number, especially when it comes to the geometric. So what I know is going on here is I am multiplying by r, multiplying by r, multiplying by r, multiplying by r. So I have a first term, I have a second, third, fourth, fifth term. And so I write this as, I ended with 768. And I got there by starting with 3 and multiplying it by r 5 minus 1 times. Again, I want to figure out these term numbers to help me figure out what that power is. A lot of people just want to count. There's 1, 2, 3, 4, 5, so I'm going to put a 5 up there, but no, it's 5 minus 1. So this is 768 divided by 3, 256, I believe, is r to the 4th. And so what I need to do is find the 4th root of r. So the 4th root of 256 will give me r. How do I do that on my calculator? There are 2 different ways, and some of your calculators have multiple options. For me, I can go above the caret key, and it has the different root key, okay? But I don't usually use that method. If I did, I would do, I hit 4 and then second and caret. That gives me that thing with the little x there. The 4 takes the place of the x, and I would plug in 256. And my answer is 4. So that's my answer here. 4 is my r. Again, I don't usually do that way. What I do instead is, and we learned this before earlier this year, or maybe even in Algebra 2 you learned it too, but a 4th root is the same as a 1/4 power. And so what I do is I will take 256 and raise it to the 1/4 power. You could put it as 0.25 if you wanted to as well. I prefer that way, but if you prefer to use your root key, whatever, that's your own personal preference. But I always think that's an easy, quick way to plug it in. And so I get obviously the same answer. All right? That's the way you'll see me do it all the time. So that means I'm going to multiply by 4. So times 4 is 12. Times 4 is 48. Times 4 is 192. And if I did this right, times 4, I should end up with 768, which I did. Okay? So our last one. Last one. Again, process is the same. I have my first term, second, third, fourth, fifth, sixth. I'm ending with the 6th term. Okay? I suppose I should slow down. I feel like anxious because we're getting close to the end. Is everybody okay with this? Feel all right? Anybody have a question about anything? So again, I end with negative 972. I started with negative 4. I multiplied by r to the 6 minus 1 power. All of those pieces come into play. I can divide by negative 4. So that is 263, I believe. Divide by -4. 243? Okay, thanks. 243. So 243 is r to the 5th. That was just me dividing by -4 to get that value. Again, that's just the algebra part. So 243 is r to the 5th. So what I do is the 5th root of 243 to get r. And again, I just raise that to 243 raised to the 1/5 power. 3 is my value. So times 3, -12, times 3, -36, times 3, -108, times 3, -324. And if I did that correctly, -324 times 3 should give me -972. I always like to double check that last one and make sure that it works. Okay? All right, so here is our start with arithmetic and geometric. Again, it should be a little bit of a review, maybe not 100% totally, but again, a big key here is making sure you can recognize whether it's arithmetic or geometric. Write a formula for it, find an